This, what you see here, is not a native text. This is only a raster picture with a text. And this is not a line, what you see. This is only a pixel trace in a formal line. And now if you convert this PDF file into CAT file, maybe you expect that we will be able to recognize this text as a native text on this line here as a native line. But this is not a conversion, because conversion is only changing a format. In this case, you can't speak about conversion. In this case, you have to speak about recognition of text. And this recognition of text name is optical character recognition, or CR. And if you need this line as a real line, this is another thing. This is not a conversion. This will be raster to vector method. And maybe you expect that it will be really a line here with a corner. Then you need a middle line tracing as a raster to vector method. There are a lot of different raster to vector methods. Another thing is, for example, I zoom here this detail. Look, so what is it? Why the circle is so in terrible quality? And this, what you see, is a PDF made by AutoCAD 2015, for example. Why AutoCAD 2015 make this kind of terrible PDF? Because the interface, AutoCAD 2015 interface, is not a real interface. This is only a HPGL to PDF transformation. Like AutoCAD 2015, for example, use a plot interface, and this plot is made in HPGL format, and they transform only this plot into PDF. And now, because HPGF plots are in DPI's raster. What is a DPI raster? DPI raster is a coordinate raster you use in your plot. Or if you print it as a raster for picture in your, for example, on your plotter, so this DPI is a resolution of the picture, and the normal resolution of a print is 300 DPI. At 300 DPI dots per inch is maybe enough for a plotter, maybe enough for print, electronic print too, but is absolutely not enough for CAD systems. And this is the reason that now what you see is a circle in a terrible quality. Why? Because this is not a circle, this is on a polyline, but this polyline represents a circle, and this polyline is here on, so you see on this DPI points. And if you zoom, for example, these circles, you will see these circles are in 300 DPI points. And now, only one thing you have to know. If the program, the CAD program, is not able to produce here well-done circles, the another coordinates will be terrible too. Now, if you will try, for example, to measure this 447 and this 350, you will be receive something with a terrible accuracy. Let me measure it. I take here, now here's a symbol. We can measure here with our viewer. I measure here snap, and I measure it. And what you see is 34486 inch. What is it? This is a plot distance. Like now, this is another secret about PDF. PDF files are not a CAD files. This is only an electronic print, and the coordinates of this electronic prints are in a paper coordinates, like in the print coordinates. Somebody print this drawing on a small piece of paper, and PDF so decide, okay, good, now this distance is 34486 inch. And now if you measure, for example, this distance, okay, come on, here. I will measure this distance, for example, from here to here. This is 2.7001 inch. And it's very interesting. If you will try in CAD to scale it so that this distance will be 350, this distance will be never 4.47. Why? Because the accuracy of this drawing is bad. And now, if you convert this drawing into, you need now a drawing in a perfect quality, you need to calibrate these coordinates. And this is what our program is doing. This is a big difference between, for example, AutoCAD 2017 in the interface. If you read the file, PDF file, AutoCAD, you receive the coordinates. Nobody take care for the coordinates. We take care for it. We calibrate the coordinates, yeah? Okay, now I want to show how it works. Oh, we have now over 44 visitors. I'm very happy about it. Again, hello to everybody and greetings from Clearwater on Florida. Okay, so this is a German word. One time I have to stop by so. A lot of guys told me after my webinar, Andreas, why you tell so much so? Okay, sorry, I can solve it, okay? But I hope you understand what I tell and you have no problem to understand my English. So, what I'm doing now. Next step, what you have to do with every file you try to convert is start the analysis of the program. And the analysis will tell you true about this PDF files. Because if you open this drawing in a viewer, what you see is only what you want to see. It's not really what is there. Because there is this very interesting phenomena that our mind and the human mind made immediately here with this drawing a recognition. And we recognize immediately that this is a text, this is a line, this is a line, this is a text. But this is not a text, not a line. This is just a picture, and this is a terrible quality, you see. But our mind in this scale tell us, oh my God, this crisp, clear drawing. This is like here. So I take now, for example, the drawing from Mike. Yes, Mike, now I take your drawing. And now you open this drawing and tell, oh my God, this is fantastic. This is a fantastic drawing, crisp, clear, and the conversion will be fantastic. But what you see here, it is not a PDF file. Because what you see here is only a Fata Morgana. This is not a PDF file. This is only a raster pictures made by CAD system. Yeah, and because then you have to start the analysis. Start analysis, and now you see what is it. There are no path, no hedge, no text. This is only one image. And now you know. This is not a PDF file. This is a raster picture in a PDF frame. Somebody send you a raster picture and decide to put it into PDF frame. And let me take another one, the drawing here, flash this one. So let me take here this example one again, and analysis. The analysis tell you everything about this drawing. You see, oh, here we have path, we have text, but we have here an image. And this table is an image. And now, what you have to do, if you see that you have in your drawing and images and raster pictures, you know you have to take care for vectorization. You don't need to use this vectorization if you don't have any raster pictures. Yeah, for example, if I take this picture, for example here, so view input. And now we have here a lot of different texts, different pictures, and look, for example here. What is it? This is not a text. You can see immediately this is not smooth. It is not a text. This is only a line, and this line represents the text. And this is a raster picture. And look, what is it here? This is not a text too. If you zoom it, what's happened here? This is again a plot into PDF in 300 dpi made by AutoCAD. And what you see here, this is not a text. This is on a hedge of a text. This is only a hash. This is not a native text. If you separate, for example, here you see this is a text. This is a native text. But this is everything, something different. This is an image, and this is here a path, like text in the form of path, and this is here field paths. Okay? So now, if you have this situation, you can go again of analysis and start this analysis, and you'll see here we separate you these elements. Now, here for this raster picture, I need a raster to vector and maybe optical character recognition of this text. Here, path. And oh, here I have a path, but this is a path, this is not a text. I have to recognize this text and real text too. Then I have to use optical character recognition for it. And now you see here the hatch. And then, oh yes, this is a hatch, this is not a text. And I need here optical character recognition. And now this is a real text. Here you don't need to do something because this kind of text we can convert immediately into DWG text. So next step is, now you know following. You have to take care for vectorization, but you need an optical character recognition for a text, because the program will never make any optical character recognition for any conversion if you don't tell I want it. Why? Because the optical character recognition of a construction drawing is a big deal, and we are not able to activate this conversion automatically, because everybody who tried the program will tell immediately this program is a crap, because this program recognizes everything as a text, every symbol as a text. You can imagine you have a construction drawing like this one, construction drawing, and here you have not only a text, but you have here a lot of symbols what looks like a text. For example, here this is maybe an O, this is maybe an O, and do you know what we see here? This is, what is it? Now, of course, as a human being, you can see we have 1, 2, 3, 4, 5 dashes. But if you will try to recognize it with automatically optical character recognition of a text in every direction, immediately the program will recognize this as 1100-111 as a vertical number. Yes, this is a vertical number, 1100-111. Why not? Of course, for us, because we are human beings with fantastic intelligence, we see immediately, this is not the number, this is a dash, this is a dash. But you can't, this kind of intelligence you can't expect for my laptop. And this is the reason that you have to tell to the program, I need this optical character recognition, and you have to show program where the program has to apply the optical character recognition. Of course, this is what I'm doing now. Now I start the vectorization. And here I decide what kind of vectorization I want to do. And Mike, in your drawing you send me, everything what you do is only to take care for this vectorization, nothing more, because your drawing is only a raster picture. And here I decide I make a center line vectorization. Yeah. And for example, so cleanup of 3 pixels. Okay, let me do a horizontal and vertical line recognition, recognition of lines at 45 degrees, circle and arc recognition is okay. But I will decide here something what is very, very important here. Under vectorization 4, I decide now that because the table has a lot of edges, that I'm interested here in edgy lines, rectangles and corners. I don't want that the program smooths the lines in the table. I need a table, more horizontal and vertical. This is what I tell the program. But this is the information only for long pixel traces, not for the small pixel traces. And maybe I will decide here following. Mix the vectorization. Let's make the vectorization for long pixel traces as a center line and outline vectorization for medium and for small details. And I tell you a little bit more. Create here hatch for the small details. I not activated here any optical character recognition. And maybe it's enough for me, okay? So let me check now how the drawing is looking after the vectorization. And here under optimization, I set here those standard settings. And now if we convert the drawing, this is fast conversion, and now we have to see how it looks after this fast vectorization. View file. Okay, and now I show you here, I'm using now here our ultimate version. In ultimate version, we connect the program with our own CAD system. You see what you see here says CADConf Connect. This is our own program based on IntelliCAD, and we offer this program now with CADConf Connect, and here we offer you a full bench on functions so that you can change the drawing how you want. Of course, if you work with your CAD system, you can still work your CAD system for this task, but we have a lot of customers, they don't have any CAD systems and they want to change something here, and they can, of course, use now our Print2CAD Ultimate. And now I zoom here a detail, and you see now here, okay, this is a native text. Okay, you can now edit the text. Okay. Moment, I have to put on the right order. This is a native text. So, but no, what is it? This is now not a native text. This is what a lot of customers say, hey, my God, oh God, what you offer? Why you don't recognize this text as a real text? Because we are not able to do it. Because we will activate this automatically in a real text, we will make so much mistakes again in this drawing that you will never want, they will not even ever to use this drawing. This is like, if you don't know this tool, we can make with this automatically optical character recognition big damage. And this is what we are not doing in our service on online service or in a demo version with the standard settings. We are not able to do it. But you can decide that you do. Yeah, I will show you how you work. Now you see, now we was able to recognize fantastic this table. Can you see it? This is everything fantastic recognized, and this is this text like before, but what we have here, this is a hatch. This is we produced here. Oh, I see I have here this, oh, sorry, because I have to change something, because my last I used it last time in a German webinar, and this is everything now in German language. I switch here now immediately to English language. Oh, see, this is in English, okay? So, and now move. So, and here we move, you can move it how you want. You see this now a raster picture. We recognize this raster. And now what's happened with this one, okay? Okay, let me check this one. Now this is a hatch. So we don't change it, and now you see we have here hatch. So we offer here everything as hatch. You can move it, you can everything, but this is not a real text. What's happened? Now you can decide following. Now I have to take care of optical character recognition. And you can go, if you want, here to optimization, text recognition, and you can switch here the automatically text recognition. But you can switch it off to this automatically text recognition only if the drawing is a small drawing, like my drawing. So only in this case if the text differences between small text and big text are not too big, and if you have only, like here, only a horizontal, only vertical text for recognition. So if you are not sure that this kind of automatically text recognition will be good or bad, you can go here on preview. And in this preview, we show you what we will now recognize in a first step as a text, as a possible text. And now you see the program suppose that this can be a text and this can be a text, and this is okay, this can be a text, this can be a text, and everything. But you see, this is not true. This was a circle, not a text. And here was something in the drawing, this dash, we recognize as a minus, like something like this. But here we are able to recognize too that it can be a text. But you see, this is a text. So the problem is here that this text is going together. Can you see it? Zoom it and look what we separate. And if you see this kind of characters here, this is what we will try to recognize as a text. Then in this case, you can be sure we will make a log of some mistakes. Okay, let me start now with this automatically text recognition. This is only something for somebody who has not a lot of time and want a small drawing, or for example, you have a text page, then you can do it. This automatically text recognition. You see, this is how this automatic recognition is working, yeah. But it's make too much errors, and you can do it only if you have only horizontal or only vertical text for recognition. If you have a mixed texts, don't do it, because in this case the automatically recognition will be terrible. And now we'll check here what we did. Now the problem is here that this was recognized like OO or the OG. So this is not correct, of course, yeah. But it's no problem, because we still have here this layer. This layer is frozen, and you can activate it, and now you see what was behind this layer. Now you can delete it, and okay, one moment, and you can take it if you want. Okay. This is what we got. This word was not recognized as a circle, but this what we are able to recognize as a circle. Yeah. But look here, what we recognize 180. But you see, the problem was automatically recognition of a text height. Yeah. We next step we try to make a homogen to this to find the best one text height, and of course this is not really compared to this text height. Yeah, let's look here, symbol reference. This is maybe okay, but this E we recognize as a 5. This is not correct. Yeah. Now we see here, and now here see this is not a good deal. So for example, we was not able to recognize here nothing because what was too small. And let me go here again to recognize. I switch it off, and see this is what we were not able to recognize, but this was recognition. You see, this is okay, you can use it, but it's not a perfect, and we want to offer you a perfect tool. Now what I'm doing, I'm going on this optimization and I switch it off. This is not the quality what I want to offer you. Okay. We want to offer you a perfect quality, and this perfect quality of text recognition you will receive only if you help our program, you help my laptop, you have your cat computer to recognize this text, and you don't need a lot of help. We need only one information: where are the texts, and what is the text direction, and we need a separation of a text with a similar height, because we need information about the common text height. So how you do it? This is very easy. It will take a few, maximum 10 minutes, but you have to know how to do it. You have to do it. Look, first you have to activate here optical character recognition mode. And now you can go here to the optical character recognition expert functions. And here on the manual text recognition of text, you can define for us text recognition areas. And this is what I'm doing now. Now the program separate, but you see a little bit more now, because the program now, the human being is now, and try to tell me what can be a text. And the program pre-separate everything what can be a text. For example, we take out all texts, all real texts, all long lines. And now you have to help the program. And you can tell, okay, here is a text with the same height. And now here. So this is a text direction, you can see? Here is the text, horizontal text with the same text height. And this is a number area. You see I push here on the left side numbers. And if you help our program and tell these are numbers, then we have no problem with 8, B, O, and 0, because O of 0, they look absolutely identical. B and 8 are very similar. 1 and L are absolutely identical. But if you tell to the program there are numbers, then we know L can be only 1, and 0, O can be only 0. And now what I'm doing here, I'm zoom here this detail, and I decide here I work a little bit more. So text area, this is my text with the same height. This is text with the same height too. And oh my God, I have to change it now. Hop. And here I have to be a little bit careful. So now let me take it. This is a text with the same text height, but here I have to work a little bit more careful. And here I have two texts with different text height. Now is everything done. We don't need more. And you will see now, after this kind of information, we can do a perfect optical character recognition of every construction plan. You don't need to separate every characters, every text separately. We need only an areas of a text with a same text height. It's not a big deal. I know. So you think of, oh my God, I have a big construction drawing and I need 10 minutes. Yes, maybe you need 10 minutes, but then you have a real text. If you don't use this 10 minutes, you have a drawing with a not real text. I know. This is maybe very broad task. Okay, then find somebody who can do it. Maybe somebody who who can do this kind of work. I see something. Okay, now I hope you can see me, because now I have now a problem here with the speed of our connection. So okay, here what you see is this is what here we can see what we find in our sample, and here what we recognize. Now you have to compare it, and if everything is okay, you go and apply, and now you will be able to see how fantastic is the now. So now look, this is another quality of raster to vector of optical character recognition. I switch here on again what we recognize a text, and now you can see this is very, very similar. Oh, let's check this was not active. Okay, and now you see here I was able to recognize this text perfect. Can you see it? The table perfect. Here we recognize nothing here as a text. Now is the recognition absolute perfect. This is now a real text, and this is very, very important information. And in the future, please use this manual separation. I show you something more here about this thing because I want to show you how you can separate a horizontal and a vertical text. Very important thing, guys. Can you see me and can you hear me in good quality? Because I have here a warning from our provider that something is not correct. Okay, for example, if you have a vertical text, then you need this text direction, and here you can tell this text. Text under 45 degree, this one. So, or text from the top to the down, so this one. So this is how you can separate it. Here's text under, like this kind of text, you see. This is how you can separate text if the text have any inclination. Good. So now, next step. Okay, we was able to recognize perfect the text, but let me open the drawing again here in CAD system. And now I will measure a distance and we check what is the quality of a coordinates. Distance from here to here. You see, this distance is 12.3 46. Now you become maybe an idea. Okay, good. Then let me scale this drawing. Scale. Okay. All. So now base point. Oh, let me take this point. Okay. Okay. And what is the scale factor? Scale factor, I make a reference. Okay. Reference. So base scale is this one. Okay. And the new length have to be 16.04. Can you see it? Up. So, and let me measure now this distance. Okay. Okay. Distance from here to here. Perfect. 60.04. Wow, good, yeah? And then you think, oh my God, now I have a perfect drawing. I can work with it. Everything is okay. Forget it. If you scale the drawing, you don't change the accuracy. Now what I did is I make only a drawing but back accuracy bigger. Now if you measure the distance here, for example, this distance, on this distance, you see this is not 9.75, it's 9.7477. Oh my God. And if you measure this distance, for example, from here to here, it have to be 4.47, but it's 4.46. Why? Because with scaling, you do not change the accuracy of the drawing. You can change the accuracy only with the help of a calibration points. And this is what I'm doing now. In the future, in next few weeks, we will offer this calibration here on the base of our CAD-Conf, or our CAD system, CAD-Conf Connect. So in the future, we'll be able here to put the calibration point, and then scale the drawing, so we have everything in the right dimensions. Now we offer this scaling, this calibration of this drawing here in OCR mode, under OCR expert functions. Here you will find here coordinate calibration. But what I'm doing now here, I switch this text recognition off, so that we don't need so much time here for conversion. And look here, manual calibration of coordinates, and here I put here now my tolerance very small, so to 0.5, because this drawing is very accurate. So the coordinates are more accurate, and I need here maybe it's 0.5. Okay, you can if you go here on help, in the help you can read automatically so exactly what is this tolerance. Okay, but now we go here on the here to the subject, and now here you can put 10, 20, 50 calibration points, and calibration point can be every time on the end of a line, because we snap to this end of a line. Don't put the calibration points like me here, so this can be calibration point. For example, here, and you can this is coordinate 100, 100, because with these calibration points you are not able to increase the accuracy, because what I have to snap here? I snap here on a pixel on a screen. So every time if you define a calibration points, define the end of a lines. And for example, you can snap here this corner, okay? And if you know the coordinates of this corner, you can put this coordinate here. And you can snap, for example, this corner here. And if you know the coordinate, you can put the coordinate. You can, if you know, for example, this corner, you can put here the coordinates of it, and you can calibrate it. And if you can put 10, 20 calibration points, you have fantastic drawing. But what I have to do? Now, I don't know the coordinates. Only one difficulty is here to find out where are the calibration points and what is the right x and y number of these coordinates. This is only one difficulty. But we offer here a fantastic method so that you can use dimensions for your calibration. Because look, in this dimension I have all the information what I need if I want to calibrate this drawing. And let me use this. This is not complicated. So, for example, what I'm doing, I snap here the end here of this line, and I decide here I decide will be my coordinate 0. But I'm not interested in y coordinate. Calibrate this one point and everything what you snap here in this area to coordinate 0. And now if this is a coordinate 0, then the next coordinate here have to be, what have to be? 1604. 16.04. You see, I calibrated now. Now the program take this will be 0 and this will be 60.04. And I snap here. Oh, moment. Oh, I have to delete it because oops. And again, hop, 60.04. And the program snap here the end of this line, because if this end of this line is this in this rectangle, it will snap it. So now I zoom it here. So let me take this coordinate first here. This is what I take, and I decide this is a coordinate 0, but okay, sorry, 0, but in y direction, and in x direction I'm not interested. Only in y direction, 0. Okay, and now the program will calibrate every coordinate, this one, everything. Oh my god, my telephone. Okay, will be calibrated as in y direction 0. Now this can be 1.25 and in y direction, and you can go through the full dimensions here. And now I can define, for example, relative point, relative to the last one is 3.44. Can you see it? And now, for example, I decide 9.75. This is an absolute point, 9.75. Why is not 75? That is this one, 9.75. Let you look again. You see, I have now 1, 2, 3, 4, 5, 6 fantastic calibration points. And you can put so much into the how you want. And now look what's happened. Now I'm going here and start the conversion, and you will see now the quality will be absolutely different, because now we have 6 fantastic points for drawing calibration, and looks what happened. So now I will measure the distance from here to here. Look, 16.04. Perfect. And now distance from here to here. 9.75. Can you see it? Perfect. And now distance from here to here. 3.44. Perfect. You see, everything what I calibrate here has now a perfect dimension, but not only this one. If we measure, for example, now distance from here to here, let me measure distance from here to this corner, 3.44. Perfect. If we measure distance from here to here, distance from here to here. Oh, moment, there's a snap here, was something wrong. Distance from here to here. It seems not to be 3, 4. Okay, I have to, this is them, okay. But this was not calibrated. Now 3 dot distance, 3.55, because this I calibrate on this one, okay, but this is not calibrated, 3 dot, and you see everything what we calibrate is better, but of course this distance will be not perfect because we do not put exactly calibration points on the mathematical methods now to change the change here the quality, but the quality is now more better. It is almost 4.7, but as I told you, this is only now mathematical methods what make it better. If you, for example, if you will define it every point on this dimensions, like a calibration point, you will receive a perfect drawing. Yes, but it takes a little bit time, I know. Okay, guys, this was everything what I wanted to show you today, and thank you very much for your attention. For everybody who has any questions, so I say thank you again for your attentions, and now we finish the webinar. This is the end of webinar. Thank you very much. I stop the recording